All right. Good afternoon, or almost evening, everyone. My name is Mark Sims. I'm with the Azure Core Engineering Group. I run patterns and practices, as well as a team that spends a lot of time working with customers and building out large Azure applications. And wanted to borrow an hour of your lives, which unfortunately there's no refund policy on, to talk a little bit about some of the experiences we've seen with customers who have experienced moments of rapid and terrifying success, and have had some learning moments in that process. Share a little bit of the pain, share a little bit of the suffering, and then talk about how things might have gone if we'd made a few small choices just a little earlier in the process. You've seen that slide already? Okay. So essentially, I'm going to walk through the journey to scale. A lot about the process, a lot about the questions, a lot about the things that help you get ready for being wildly successful in a website or services delivery without having to over-engineer or overbuild up front. Talking about systems that can experience rapid growth or demand spikes, and what are some of the things you can do to get ready for that. It's going to be mostly architecture, mostly design decisions, engineering trade-offs. Won't be a lot of code in this one. Will be a lot of stories. There will be intense amounts of sarcasm and occasional bits of mockery of things I've done. If that's a little overwhelming, there's lots of other great sessions going on right now. But other than that, let's dive on in. It's a good way to spend an hour together. No one ran out screaming? Cool. All right. So we're not going to talk a lot about features. Regardless of the technology stack, you can pretty much drop anything in here, and the same set of physics and the same set of engineering choices apply. We're really going to talk about the journey, not the destination, and the things you can do along the way. We're mostly going to talk about scale and availability being very inextricably tied together, and how to leave the door open for success without overbuilding. Some of the stories I'm going to tell, they're either slightly anonymized or details have been blended together so as not to kind of give away what really happened. Because we'll talk about the success stories, but no one likes their dirty laundry aired in public. All right, so this is a direct quote that showed up in my inbox, so let's call it 6 months ago. It wasn't 6 months, but for the perspective, for this talk, let's go. So today has been a complete debacle. I do not understand how a website can crash immediately upon receiving traffic. Yes, this was from a digital marketing agency. So any idea why a website might crash immediately upon launch, assuming that it is functionally correct and has passed all unit testing? Let's run some numbers, shall we? 30,000 requests per second in the first 4 minutes. But we go, but this is Azure. We can build some big stuff on this platform. We're rock stars. Okay, now let's dig a little bit deeper. Okay, then. I think, okay, I'm actually fairly glad we didn't have a machine in the data center physically catch on fire. Kudos to our build-out teams for thinking of fire safety. But just to tap things off. So, amazingly, wildly successful launch for the first 250 milliseconds. And then after that, things started to get less good. The funny part about this particular story is I was flying down here to San Francisco to visit a customer. I'm on whatever the version that flies around here is. I've got my GoGo internet. I'm reading through my Facebook feed, and I actually see the site in question, the individual basically saying, hey, you guys are really smart. You took my thing down. And I'm thinking, well, I'd love to help out and make this thing better. And then my link rings and goes, yeah, we've got an issue. Can you help out with it? So this one's actually kind of near and dear to me. So keeping this sort of situation in mind, let's actually go through what the agency could have done without overbuilding or overspending a little bit along the way in order to be ready for this. And because 30,000 RPS, it's quite doable with the right architecture, with the right design, and giving us the right amount of money. We like that last part. Okay. So we're going to frame a discussion around 4 axes. So all of the Azure Customer Advisory Team depth engagements, when we think about architecture, we're always looking at these 4 things. They're a great way to frame the non-functional aspects of the system. Functional stuff, as nebulous as it is because you're working with humans, and it's a little fuzzy, these are the 4 that will kill you in conditions of success and at scale. Scalability being 2 things. Can I add more resources to the system efficiently? That being, can I add them and can the system use them? Can it marshal them? And am I using the deployed resources effectively? This is probably the single biggest change moving from a closed world enterprise system where you can literally name every single user because they're probably in your global address list to going to open world dynamic load and growth systems where you don't know who's going to show up. And if you're wildly successful, the world is going to show up. Physically, the biggest change is we're used to capitalizing for 36 months out. I'm going to look at my fairly structured load profile. I'm going to think, how big a set of servers do I need to buy for 3 years from now? And I'm going to amortize my CapEx across them. Fantastic. I've grossly overpaid for all the stuff I'm not using, and I'll replace them in 2 years anyway. Luckily, in the cloud, we have more options, but unless we plan appropriately and we can add more small units of work, this doesn't work out so well. And some of the inefficiencies that you can get away with in a world where you have lots of extra capacity, they don't play so well when the world shows up on your door. Of course, availability. You get enough stuff, everything fails. Every single thing is going to fail under enough time, enough pressure, and enough humans, because humans are the leading cause of outages. So who's ever fat-fingered a config file update and brought a system down? If you don't put your hand up, you probably weren't paying attention. I've done this. Configuration is actually the most dangerous thing to availability, because it is the one piece of your code that has no error handling. I have seen two systems in my life that didn't trust their own configuration. Almost everything explicitly trusts its configuration, and it's the easiest thing to live edit on a system. But we'll talk about that when we get to ALM. But the single most important one of this list in terms of operating a cloud service or a large-scale web application experience at scale is manageability, telemetry, and ALM. Do I actually know what's going on my site, and can I make changes? Twitter is a very effective site availability tracking mechanism. Very effective, because the world will tell you you're down and you suck. I would like to explore some options to have Twitter be the thing that doesn't tell you your site is down. And if you're doing platform development, if you're building release over release over release, feasibility, is the system simple enough for your dev team and your budget to be able to keep building out new releases without accumulating absurd amounts of technical debt? Because we all love paying down technical debt when we have time, and because we all have lots of that. So 4 pillars, make sense? Good way to have a discussion? All right, cool. Moving on. Really going to hammer on this one because even I was talking to one of my guys today, and he was having this discussion and hadn't actually conflated the two sides of scalability. Can I add more capacity? I can go and get 1,000 VMs, but can customers get to them, and can the VMs, assuming they're stateless, get to their state or to the piece of state that they need? And really, this is all about where are the marshalling points, where are the contention, where are the choke points that I need to be aware of? How do I add more capacity efficiently? And subtle considerations, especially with regards to mobile applications requiring push notification. We'll come back to another story on that in a second. And then the using capacity more efficiently, density, traditional performance tuning, avoiding common anti-patterns, and identifying things like unbalanced workloads. The one we were kind of talking about thus far is a publication workload. It's 99 reads for every write. There's a bad joke in there, but I can't come up with it right now. So, a traditional CMS, a content management system, the way they're traditionally architected assumes 1 read for every write because they both hit a highly consistent database. It says that all of these are equal. They're not, especially in conditions of success where one person might edit 1 file or 1 piece of data, and then 1 million reads need to happen on that. You do that directly against a single centralized SQL server. You've either bought a giant SQL box or a giant G series or a P3 or P4. I'm okay with you want to spend more money than you have to. May even encourage it a little bit, but that's not today. Versus going, hey, this is primarily read. I want to spread that thing out. All right, so design considerations. First set of questions to go through. What kind of application or service are you building? It all comes from here. Is it a burst mode application? Is it where everything has to happen on a single day at a single point in time? Is it something that needs to run only 9 to 5 but can't fail between there? Is it something that's primarily read? Is there a lot of read and write? And the question I've started to ask now when working with customers is what portion of your budget, your actual dedicated engineering budget, heads, time, tooling, everything, is dedicated to the non-functional service fundamentals. If you're doing a platform and that number is 0, you will have a production learning moment, and they are not fun. There's a less polite term we use for them, but I can't use it here today. So, does anybody actually have this baked into their budgets? A couple hands. Cool, I like you guys. Did you have it baked in the first time you did one of these? I didn't. Okay, so let's go in 2 other things. We've all heard of Yagni. You ain't gonna need it. a couple nods, a few heads. What's he talking about? Well, when you get into conditions of wild success, there are occasions where, oh yeah, you really did need that. And a lot of the balance is going to be the how do you frame the door, how do you create the conditions for success without having to do all the work way, way, way in advance on spec. And really finding that balance between testing before production, because let's be honest, you're always testing in production whether you want to or not. Just accept it. Really what we're talking about is making an engineering decision of how much effort are we going to put in to fill in how much of the test space to prevent outrageous surprises. But people will still do weird things, which is where we come back to telemetry. Okay, so let's talk about a scenario. This is kind of mashed up. It's an amalgam of like 3 or 4 different customer scenarios. So let's think about building a website with an accompanying mobile application for tracking sports events. This is actually from an internal test service we use just for understanding various service behavior, flow, best practices, and whatnot. And we're going to have 2 key characteristics. We're going to have burst mode, meaning that on certain times of the day or certain daily events, there's going to be a game on. And during that game, everybody's going to show up, and then everyone's going to leave. So we have these, in this case, predictable spikes, calendar-driven spikes. But what we also have is a virality event, potential growth, because there's some social aspect in here, where, hey, I'm going to go, for example, this was fantasy football, because no one's an addict about that. Or at least I'm told I will be this fall. As the social graph grows, you can also get these tipping points. So when these 2 come together, you can actually show up with a lot of success you didn't anticipate. So those are things to watch out for when you're designing a class of system is, can it burst? Do you know if it is? And if you can predict it, that's good, or at least if you can schedule it. And can you get wildly successful based on basically a tipping point in your user base? If these are closed world enterprise targeted applications, you don't actually have to worry about a lot of this stuff because your user motions don't enable it. But in this case, we're going to target the hard ones because it's build, and let's talk about some hard fun stuff. All right, workload decomposition. This is key. You need to understand the flows in the system and their relative prioritization. There are more. I just pulled out 3 interesting ones. And really what we're looking for is how stateful are they? What is the span of data they touch? And is it mutable or immutable works? So for example, listing out a sequence of games, it's pretty much always a read workload. You're going to update your schedule once every now and then. In fact, for many sports events, you know the schedule 6 months in advance, and it's not changing outside of an exceptional event. So this is a minimal consistency requirement. If it takes minutes for the data updates to flow through the system, that's okay. So there's a certain range of options we can use there. The status of a live event, well, that's a little different. It's read workload, it's continuous concurrent updates, and I don't know, it really comes down to your user base of, can I take a second of read consistency? Can I take a couple of seconds? It really depends. Anything below a second because of network transmission times doesn't really matter all that much anyway. And then status of active events with mobile. It's exactly the same as the prior one, but we have push notifications. And push notifications with consistently connected sockets puts a really interesting type of stress on a system that doesn't exist in web workloads. Because you're testing not just how much work you can do, you're testing how many active sockets can be maintained, which puts an interesting stress on your network infrastructure. And guess what? No web testing workload out there, the web test tools, guess what they don't stress? Sockets. Story time. About 6 or 7 months ago, got a call, nice, calm, reasoned call at a good hour. No, it really wasn't. It kind of went like, so yeah, we just landed our biggest contract. We had this live event with our great little mobile application that worked fantastic on my desk. We've all heard that one. And we went tracking this live event, and my world melted down in 5 minutes. But we tested this at bigger user loads. You're like, okay, so we're missing some piece of data here. Dig in, and go, oh, so what you guys actually tested was how many requests per second you could push through the system on like 10 network sockets. What you didn't test was, what if you turned on 1 million active sockets? Did you have enough infrastructure deployed to handle that? The answer is, well, no, they didn't. So because a low fidelity test created a false sense of confidence, and we'll get to the other things that they did that were bad in a little bit when we talk about manageability. So again, having this list, this doesn't take long to put together. Just what are the key workflows through the system? How stateful are they? Are they read? Are they write? Where does the data come from? Do I need data for a particular user, or is it system-wide metadata? All right, so stage one. Pretty much, this is what we've been told to do for the last 15 years, and for a certain class of system, it works great. For highly dynamic, fungible, bursty workloads, this is pretty terrible. You could replace this with Linux and LAMP. The physics are the same. It's still very, very bad because we can't add any resources easily. And I'm also managing this at a very low layer of abstraction. If I just want to pump out a website, I don't want to manage from the transistors up. That's old school. That's not how we want to do these sorts of things anymore. I don't need that much control of my VMs to be successful. So we get to see a lot of these. In fact, this has three times as many servers as that first item I mentioned. So we were already a little bit ahead of the game. So let's go through the process of figuring out how do we establish our baseline? Where are we to start with? OK, so capacity. It's really hard to add capacity to this system because I would need to manually configure a VM, get my patch levels right, get my software on there, get it configured, add it in, integrate it with the load balancer. Anyone watch, actually, Corey Sanders' presentation on how to use the Azure Resource Manager is right now, so you're obviously not watching that. We're making this part easy, but it's still, I'm managing VMs. And there's a lot of moving parts there. The other part is around density. So a default Windows Server installation with IIS is tuned to protect the server. Very perfectly reasonable things when you expect to host multiple workloads on a VM. If instead you're in a cloud world where it's dynamic, it's fungible, I add VMs, I remove them, I don't want to protect the VM. I want to protect my investment. I want every ounce of CPU. I want every ounce of memory, every ounce of disk, because I can dedicate VMs to specific tasks because they're easy to spin up and tear down. So if you have the default settings, and unless you go through and, to be honest, properly tuning a web workload on IIS to reach its rough maximum, which, depending on your code, is about 23,000 active sockets, SSL, per core. That's what you can do this, as well as 15 to 20,000 ops per second in a fully asynchronous mode, well-tuned. It's about 300 settings. So you probably don't want to be in that game unless you have to. And unless you're targeting systems that are doing more than 100,000 operations per second, you probably don't need to do that. OK, so other one is density. How efficient is my code? How efficient is my configuration? And how well am I marshaling and using resources that are available? Key questions to ask. All right, I have 3 VMs. Each one of them is a single point of failure. So in this case, everything is a single point of failure. I cannot survive the loss of any single piece of this infrastructure. Probably not great. We'll make it better. But the most important thing of all is knowing where we stand, turning the lights on, as it were. So that diagram I showed before, operational insight and visibility, how much do we think we really get by default? A lot of head shaking? This is kind of what you get. Unfortunately, most of the times, an escalation lands on my team's desk. The first question we ask is, show us your logs, show us your telemetry, help us understand. And the answers range from, we don't have any, it logged too much, so we turned it off. I know, it sounds funny, but if you think about it, this is the way we've been conditioned. We used to have tests where we turned on lots of telemetry, and we knew how the system behaved. And then we go to production, and because we had these capitalized, very expensive scale-up workloads, that was really, really expensive to do logging, so we turned it off in production, which is a really neat way of saying for 15 years, as an industry, we deluded ourselves into thinking that it was more important to know how a system behaved in test than it did in production. Think about that. Or yeah, we turned this thing on, but we never looked at it. Back to that web application, that mobile application that melted down because there weren't enough sockets, they actually had a live monitoring service. It was actually, in this case, it was New Relic, turned on their site. But no one had ever looked at the data because the dev team was here, the ops team were here, and they weren't talking to each other. So there wasn't this understanding that this is a cycle. This has to be connected. The devs didn't know how to log into the portal, and the ops guys didn't know what the code looked like. So when we come in and going, guys, what failed? They looked at us and go, well, Azure failed, obviously. Because in absence of data, it's always the platform's fault, which might make you feel better, but doesn't really help in root cause analysis and remediation. So this is actually the first thing you have to solve when you're preparing for success. The good news is you can rent your way. So 3 things we have to do. We all have limited resources, time, people, and money. If you have unlimited of any of these, let's talk. It could be a fun place to work, temporarily. So how to prioritize? We need to frame the door. We need to set the stage to be able to deploy more capacity and resources without having to change code. Because changing code in conditions of extreme success is horrifyingly bad. It's very terrifying. I just want to run scripts and add resources. I need to turn the lights on. I need operational visibility so I know if I'm actually making something better. Has anyone ever heard me use the term psychic debugging? We see this a lot, where we come in and going, well, why did you change that? I don't know. I just wanted to change it and see if it got better. OK, that's not unreasonable. How did you measure if it got better? We watched Twitter. In conditions of crisis, when everything is failing, it's just a natural human reaction to scramble. And unless you build the discipline of data-driven engineering up front and you practice it on a daily basis, you won't have those patterns to fall back on when success is just within reach. And you will not, bluntly, have time to do this during positions of crisis. So it's always better to make the few small changes up front. But most importantly, we're going to use this data that is very easy to get on a modern cloud system, especially in Azure, and we'll use to drive this to understanding of what engineering investment do we need to make now, what engineering investment can we make later, and what's the difference? Because most modern systems are pretty complicated. There's a lot of moving parts. I do a lot of IoT-based solutions, and a simple IoT-based processing system can have 300 to 400 workflows. You cannot tune 300 sophisticated workflows in a day. But more to the point, you only tune 4 or 5 of them to be successful. So we need data. All right. Also, how do we get out of this race of managing at the transistor level? It just takes time. And we want to focus on business value, getting features in, and not having the pager or the virtual pager. Who remembers pagers? Age check. Come on. Yeah, everyone will admit it. PagerDuty now and similar services. So how do we make it easy to trade money for capacity? Now, sometimes you need a lot of control. Sometimes you need the whole VM. You want to go deep. But for most web applications, especially the front end, it's not all that necessary anymore. So money is almost always faster to spend than engineering time, and it generally carries less risk. And a lot of times what you may do in conditions of success is let's spend a bunch of money, roll out more capacity to get us over the hump, to buy us the time to do the right engineering work. All right. And in Azure, how do we look at migrating and rehosting application components to their PaaS equivalents? How do we go semantically up the stack? How do we trade IIS VMs for web apps, formerly known as websites? I may call it Antares, sorry, code name. But that is, you can basically take your web code, rehost it in a PaaS service where we've already gone and done those 300 plus configuration settings. True story. In my role as the manager of patterns and practices, we recently released a bunch of guidance on common performance anti-patterns. And there was one around synchronous I/O. And this had blown up a number of customer sites. So we were doing our testing in Azure websites, and we could not break it. We literally could not make this condition happen. And what we realized is they'd actually gone in ahead of us and done such a great job tuning the platform, we couldn't break it in this specific way. Whereas if you just took a standard IIS VM or a web role, the thing would have snapped in minutes. So we have put a lot of work and a lot of time and energy into these PaaS experiences to basically make them friendlier and share and amortize some of that learning directly into the platform. And for an application like this, there's actually not a lot of data. I need a lot of readers, but I don't know a lot of data. So being able to get that out of a SQL server where I'm managing everything and into Azure SQL DB where I get continuous point-in-time backups and a really cool new feature, automatic geo-replication, which we'll get to later, can really help me set the stage for scale. All right, so used to be, if you wanted to do insight telemetry, you had to build a lot of stuff, and that's expensive, and it's actually, in many cases, hard to justify in your budget unless you're actually building a platform where you can amortize the investment. So to be honest, I really don't care what you use. Use App Insights, use New Relic, use App Dynamics. They all have free trials. Just try them. At the end of the day, it's going to come down to what does your dev team and your ops team enjoy working with? What are the ones that help them understand behavior and flow and actually make sense of the data? And a lot of times, it's just going to come down to individual ergonomics. Just put some time in the budget and just try them out. But rent your way to victory. For more sophisticated platform apps, you may need to go and build a lot of custom stuff. That's a different talk. But for most websites of this perspective, this will get you most of the way down the road. You may need to add more later, but just get going with these sorts of things. And You actually have to look at the data. You have to incorporate it as part of your daily experiences. All right, so every single system that's ever been built, mechanical, hydraulic, electric, software, they all have a breaking strain. There is some point where you will put too much weight on the system and it will snap. There are two choices. You find it or your users will. One of these is less heartburn-inducing. Normally, the way I recommend doing this is to essentially do a destructive load test. Take the system, dial it down to the smallest resource pool you can find, one VM or one instance in Azure Web Sites, and just throw enough load at the system to find the point where it goes nonlinear and snaps, because that will tell you how efficiently you're using resources on that system. That will tell you about contention points, it will tell you about density, and it will give you some understanding of the scale unit. If one instance can handle 1,000 users representative before tipping over, then you can extrapolate to a certain point. It's not completely linear because there's other factors at play, but it's a nice, cheap, quick way to find out that, oh, hey, we actually have an internal lock being used in this app domain, and when you take it above 10 concurrent users, the whole thing tips over. Find these early, find them cheap, because they're in there. But most importantly, this is the data that will inform, do I actually even need to do any performance optimization, or can I just throw more money at the problem and keep my engineers working on features and functionality? Or do I really need to tackle specific performance optimizations to hit my goals? But do it on data. All right. Clicky thing, work, there we go. So this is an AppDynamics screenshot. This is actually from the PnP Performance Optimization project. Again, we want to use Insight against a live system to understand the load profile. And if you see weirdness, almost every time I've talked to a customer and they've gone through this process and they've had a live site event, they may go, yeah, actually, we saw this like a month ago. We just didn't know that that little hiccup, that weird piece of data, meant something was terribly wrong. You won't have time and resources to chase every single thing down, but it's worth taking a couple of extra minutes and seeing, well, hey, is our load harness broken? Or, oh, actually, there's actually an interesting bug in this system. And I'm going to keep coming back to telemetry has to be part of your day-to-day life. If you've rented it, it's cheap, it's accessible, you can do lots of great stuff with it. All right, so we have limited resources. How do we prioritize? First thing we need to understand is what are the availability points and how do we mitigate? And, if I have one single point of failure that can take everything down, you can be guaranteed that is the thing that will fail at the point where you need it the most. And what are the scale bottlenecks and the contention points? How does data flow through the system? And where do you have units of 1? There are only 3 numbers. I'll come back to this. The 3 numbers are 0, 1, and more. 0 is easy because there's nothing to do. 1 is terrifying because everything ends up there. And n is a little bit more achievable. So we'll go through and figure out how do we add more stuff. OK. So assuming we've already ported our site over to Azure Web Apps, I'm going to keep calling it websites, and SQLDB, what are the metered resources? Where are the things that are consumed? So in the case of Azure Web Apps, I have compute instances. I'm running VMs. So by default, on a normal subscription, I can get up to 10. And well-tuned code, that's a lot of. But if you need more, you can call us. And again, it's not a technical limitation. It's actually a billing and a fraud limitation. And we can crank that up. We have some very large internal dedicated clusters that are available if your application demands it. Well, the reason I keep pushing on the mobile apps is that concurrent active sockets, WebSocket connections, that's a metered resource as well, and it's not always an obvious one. So if you have a lot of continuously connected push-based notification by SignalR, you have to take that into account. You have to be able to test that as well. It's actually pretty hard. Requests per second for VM really comes down to efficiency of implementation. If you have purely synchronous code, it may not be as good. If you have blocking calls, if you have dependencies on externally metered resources, authentication being the most common one, there will be, you can only get, it doesn't matter how many VMs you add, you will only get so much work through the system. But there are n web apps, and there is one database. OK, that's a bit of a red flag in terms of potential scalability, because I have no way, I can scale up from standard P1, P2, P3, P4, but that, depending if I have particularly inefficient code, that may not be enough. A common one is the number of connections to a given database. The default ASP.NET connection pool size is 100. A standard SQL database gives you 180 connections. So with 1.8 VMs, under conditions of success, you've just blown out your connection pool. Again, not hard to fix in advance, not challenging to fix when you've identified it in load testing, kind of terrifying when you're live editing config files on a website. And database throughput. If you have particularly bad database queries that choke out or take a lock escalation that only happen every now and then, they'll take down your site during conditions of success. So just understanding that those things are there. We have a great article on the ACOM, so the Azure COM documentation, that lists out basically all of the metered resources for each of the services. Take a couple hours, work your way through, understand what those limits are and how to add more. All right. This is like the slowest clicker ever. There we go. Failure and availability points. You can have bad code. We all have bad code. I've written bad code today, and I haven't even opened Visual Studio. So, oh, come on. That was funny. By and large, IIS as a container is designed to save you from writing particularly bad code, in that if it crashes, we'll just build it back up again. There is one small exception to watch out for in IIS 8 and above. Has anyone ever configured fast failure detection? Does anyone know what I'm talking about? I didn't until last week when I was helping a customer fix an issue. So something we added in recent versions of IIS is essentially a fast failure protection or a circuit breaker that says if you just drop n number of times in a certain period, we've deemed that you are completely unhealthy and will shut you down. That feature is enabled by default, depending on the mode you're running in. So if you get into this continuous failure cycle, you may basically just get IIS turning itself off, essentially. Something to watch out for. The bigger problem here is the single SQL database. If you have any transient or enduring effects, they'll ripple all the way back and they'll affect everything because there's only one of these databases. But this is traditional, good performance tuning, efficiently using resources, but more importantly, we'll get to something in a second where we really understand splitting that read and write workload. All right, so can we reduce or shift critical work for differential workloads, mostly around playing consistency games? If I have a million people that I need to basically update a sport event or kind of the latest score, going to SQL on a single row select every single time is probably not the most efficient way I could do that. I've seen a lot of sites that do this. Now again, you may not want to invest in things like caching up front. You probably do, by the way, but you might not. Here, one of the things to watch out for is have you structured your code in such a way that you can add these things later. If you have a bunch of, say, web API controllers that have direct ADO.NET calls embedded within them, there's really nowhere to mediate. You can't go in and shim in caching. If you have a repository pattern and you at least have a place you can hide that, it's a little bit less risky. About 2 or 3 years ago, we got a call, very panicked. Hey, we're going live in 24 hours. For a governmental app that's tracking, basically a live event the next day, and the system tips over past 30 users. I'm like, okay, interesting. I feel badly for you. What are you doing? And every single time someone logged into the site, they would hit SQL 14 times and render the page. It worked great on my box. Load testing was left too late. And all of a sudden, we had an overnight binge of essentially rewriting the code base to add caching. Not my most fun evening, especially since we didn't have a lot of time for adequate testing. These things, they happen. So the really difference between this kind of approach and some of the other ones I'll talk about is this requires engineering time. This requires code change. This carries higher risk and more latency. It's just going to take more time to do it. So you never want to be adding caching or these other types of rippling changes to a live production site. It's a badge of honor, sure, we've all got the scars, but you probably don't want to do it twice. All right. So, talk about caching. Caching, like anything else, it's not a magical solution. In fact, in some cases, it'll actually create 3 problems for every one it solves. However, we've already done our workload analysis. We know this is a primary read workload with low consistency requirements. Okay, then sure, I can cache. Absolutely. In Azure, Redis caching, fantastic, easy to add, good semantic support, very scalable. And basically, well, then what I've done is I've taken my, my not overly scalable, not necessarily I've taken my single point of state, and then I've traded off consistency and spread it out to a bunch of Redis nodes. But this doesn't necessarily give me a distributed solution, because in something like this, I'm still hitting the same key, the same partition, the same set of data inside Redis. So I may employ a multi-layer caching solution. For example, if I've structured my code correctly, I can turn on ASP.NET output caching or even IIS output caching on the REST calls that render the sports scores, if I designed it that way from the beginning. And then I can basically have multi-layers of caching and truly have that state stored in a couple different places. So again, caching not magical, just another tool in the box, but can be a very useful one. And how do we figure out if it worked? A/B testing with telemetry. Turn it on, hit it with some load, see if you basically regressed or advanced. Again, this is from some of the performance optimization stuff we have published on GitHub. All right. So we actually see, to the 90th percentile, the same set of issues around density happening again and again and again. Chatty I/O is probably the worst. ERP systems that target multiple databases are perhaps the worst offenders, because when you say I'm database agnostic, what you're really saying is I'm the lowest common denominator between all of these databases, and I take advantage of none of their features to make them run faster. Even we don't like to admit that, but that's largely what you see. Or the other one that triggers a lot of chatty I/O is blind faith in ORMs. Okay, you guys been there. You know what I'm talking about. Or my absolute favorite, the difference between IEnumerable and IQueryable. Okay, a few laughs. For those of you who aren't familiar, IQueryable means take my question, send it to the other side, get back just the answer. IEnumerable says give me every answer and then let me pick. Common point, your test system has 5 rows in the metadata table. Your production system has 1 million. I'll see what happens there. That's basically another example. There's extraneous fetching, fetching the whole database and then filtering client side. It doesn't show up until you load test. No caching, synchronous I/O. We've got a full list. It's up on GitHub. And if you want a lot more detail on these, Mark Russinovich is doing a talk tomorrow at 11:30 a.m. at Hall 1B, going through 8 or 9 of these in a lot more detail. And I don't want to steal his thunder, because then you get mad at me. So we'll just move on and talk about the how do we add more capacity. All right. So if you have high-fidelity load testing, you can use your telemetry data to figure out, do we need to optimize, where do we need to optimize, and how far do we need to go? The thing to watch out for here, the anti-pattern, the regression, is if your load profiles were not based on real user data or a good understanding of real user data, you'll actually tell yourself lies. Like my friends who had the mobile app, they had great load test numbers that said that everything was fantastic, except for their load test wasn't actually testing system resources of real use on a real site. Easiest way to do this, especially if you have a couple of real users, or if you already have a site in production, just look at the telemetry, model out the workflows, and then pull that back into load testing. But the biggest thing is don't try and optimize everything. It actually, at the end of the day, most of it doesn't matter. Observe, measure, change, react. Go make sure you can basically say, on this build, this version, we got this much load for this many resources, we made this change, we got better, we got worse, we moved on. Most of the time in the systems I've seen, if you only hit 2 or 3 of the primary workflows through the system all the way down and all the way back up again, you generally hit your business goals. Going in and just doing these global optimization exercises without targeted data, you end up spinning in circles and spending a lot of time and effort. All right, so mapping the 3rd stage of the journey. We've talked a lot about, in some fairly high-level detail, but again, this is a 200-level session, about the questions and the decision matrix and the journey for getting to a good single data center solution. But we're global. We have customers all over the world, or we could have customers all over the world. We want to think about multiple data centers. We think about redundancy. So how do we go from our now truly awesome 1 data center solution to multiple data centers? This has been a big thing for a long time. Who's ever set up kind of database replication across data centers? A couple hands. Is that a barrel of fun or what? Everyone's like, no, that was terrible. And because traditionally, setting up all the hardware and the physics and the rollover in order to be able to actually run in multiple data centers for business continuity, disaster recovery, or even just global scale reasons was very challenging. I'm not going to do a live demo because I don't believe in doing those things in architecture sessions, but I will talk about a path and a process that you can use to basically go from, now I've got my 1 data center, how do I start adding others? But more importantly, why does each step along the way work? I didn't highlight this at the beginning, but you guys are, of course, free to ask questions at any time. I know I got through 40 minutes before I mentioned that. I figured I'd give myself a little bit of a break. But as long as no one jumps on a microphone, I'll just keep going. And if you do, depending on your question, I might keep going anyway. just saying. All right. So again, there are only 3 numbers, 0, 1, and lots. I know lots is spelled N, but it's still lots. And ultimately, as long as we have the ability to use N resources in any piece of our system, we are now ready to simply tell the platform, give me more of this thing, and my system will know how to take care of it. Using 1 storage account is easy. Using 2 storage accounts is substantially harder. Going from 2 storage accounts to 3 storage accounts is usually really, really simple. Of course, in the case of storage, you guys saw the Azure Data Lake discussion earlier? Announcement? Anyone go to the keynote? Anyone not fall asleep? So one of the things we announced earlier, and again, there was an enormous amount of information there, so I wouldn't expect all the, you guys need some time to digest it. To be honest, I need some time to digest it. I don't know half what we announced. We're just getting too good at building stuff. So one of the new services, the Azure Data Lake, essentially says, this whole composing multiple storage accounts for scale, that's hard. Why don't we just make that easy for you? And we'll give you the illusion, the facade, a tangible illusion, because you can't reach out and touch it, of we'll do all the magical work behind the scenes of composing all these storage accounts, and we'll just give you one head end for it. So in that specific case, going from 1 storage account for data manipulation to N storage accounts is you can do it yourself, or you can use an Azure service. We're looking at enabling that across broader pieces of the platform, but we're not quite there yet for everything, so you just need to account for it a little bit. For working with databases, if you actually have a lot of data, then things like ElasticScale will really help there. That's a way to go from 1 to N. But in the case of the scenario we're working through, it won't help because there's not that much data. It's almost all metadata anyway, and the problem really is publishing it, not changing it on the fly. So there's 3 things we need to think about in this specific case, each with their own set of resources, their own state management, and their own affinitization in terms of how do you find it and how do you use it. There's the front end and mid-tier web resources. These are relatively low state. All I really need to do is get code replicated on a continuous basis to N data centers. There's a little caveat there, and we've got a thought what that little caveat might be about having automatic global replication of updates. It also means automatic global replication of mistakes. And I'm actually being very serious here, in that one of the things to watch out for when you're doing these continuous update cycles is if there will be code bugs, there will be mistakes, there will be errors, and essentially if you've set up the ability to automatically roll stuff into production all over the world, that means that that mistake is not isolated to one place or one test environment, it's now everywhere, and you have to try and claw it back. All right. Back-end database, highly stateful. And in this specific workload, I need some form of eventually consistent data replication. I need a way to basically have that data be local to a number of other data centers, either in the cache there or in an actual database there. And I need to be able to take users and then spread them across all of these front ends. So, seem pretty easy? It's actually not that bad. It's the little details that get you. So let's just kind of go through a little adventure here now and meander through some stuff we can do. So let's start from our barely visible, sorry about that, 1 data center deployment. So we've got Azure Web Sites, we've got a number of production instances, and we are using the staging capability of Azure Web Sites to put our changes, our new stuff, in a special staging environment so we can ensure that it's functional before we flip the bit over as an atomic operation. We have our database with this subtly named P, we'll get to that in a second, as well as a Redis cache, because we've decided that we need caching here. The key starting point is I need to be able to stand one of these up through automation. I can't be in the portal clicking on things. It's great for exploring, it's wonderful for dev test, but the harsh reality is by the time you're looking at doing global data center operations, you must be in a fully automated state. Good news is, with the release of the Azure Resource Manager stuff, this can be a deterministic operation. We say, this is what my environment looks like. Please deploy one of these. We're getting out of the world of imperative programming, be it PowerShell or CLI, into the world of, this is my environment. Please clone me one. But you need to make the upfront investment so that when it comes time to push out the update, it's run a script, not get 4 or 5 people doing the headless chicken dance going, can you email me the updates so I can check them in and do the build on my machine? I have unfortunately worked with customers for whom email was their source code control system. And there's two sides. I want to go, it's 2015. Git is awesome. But at the other time, I realize under extreme pressure, we fall back on the obvious and not always optimal paths. So that's why we need to make these changes in advance so that the easy path is the right one because we're so used to doing it. All right, so first thing we're going to do is we're going to get automated publishing set up. So Websites has this really great Git integration feature. So when I push a new build, I can get an automatic build and then deployment to staging, which I can then manually promote after doing load testing or operational smoke testing. Again, automated global deployment creates learning moments. We don't need any more learning moments, especially not in production. It's a really great feature, works nicely, and it's a really great integrated aspect. The challenge is this only works if you also have a good branching structure where you have clean RIs and FIs into basically the thing that goes out into prod. So you'll need a little bit more upfront investment in your ALM process. But is anyone using, a lot of folks using Git? All right, you guys put your hands down. Folks who are going to try out Git, it's everyone else in the room. Actually, whether you use centralized version control like TFS or use decentralized like Git, it really is a matter of culture and preference, as long as you're using one and using it properly. So as long as you get good branching and merging, and everyone knows this is how my changes go from a feature branch or a developer branch into staging and then out to the kind of the test site, you're in good shape. Second thing we're going to do is we're going to make sure that our telemetry services are enabled and they are flowing data. So here's one of the gotchas to watch out for. When you set up App Insights or New Relic or App Dynamics or whatever you choose to use, you need the way to basically name the deployment. And they all do it slightly differently. And the reason is, in production I have version 1.0 prod. In staging I have 1.1. And unless there's a unique identifier that basically identifies the topology, you're sitting down looking at the dashboard with blended data. And you have no idea, well, is this the new one? Is this the old one? Is it good? Is it bad? So again, that little bit of upfront work in terms of here are my environments, here is the version associated with them, here is basically the unique stamp so that I can go back to my source code repository and recreate that golden build. Because if I need that, and if I'm going to roll this out in a different data center. And everything is ready is to basically get us ready to go from 1 to N. And our operations and the dev staff, who really should talk to each other from time to time, find it helpful, they must be comfortable working with that data. They must be able to slice and dice through and use this as part of their daily exercise of going, was that a good build? Did it do the right things? Did we have regression? Is it on? All really good things. All right, so we now have what would be considered a pretty good 1DC solution. All right, so the first thing we're going to do is we're going to stand up Azure Traffic Manager to set the stage to go to end deployments. We're still just going to have one data center, but we're going to front end it with Azure Traffic Manager with the appropriate DC changes that basically says someone comes to you and you're going to resolve to DC1. I'm not going to make any other changes quite yet. And then we're going to test that and make sure everything's fine. Again, it's all about iteratively setting the stage and have the ability to go back at any point if you make mistakes. So, next thing, we roll out the additional data centers. Again, script, change the topology, pushed out. We connect these other data centers to Git publishing as well, so they get the continuous feed of updates. But we don't put them on the Azure Traffic Manager quite yet because they don't have any data. Okay, so far so good. And the title on the slide is wrong. This should actually be global rollout, but I added this earlier today. Don't tell anyone. So almost the last piece we're going to do here is we're going to use a really, really cool new feature, or relatively new, in Azure SQL DB called georeplication. And what we're going to do is we're going to go and say, hey, DC1 is my primary. I'm one to basically, you, backing system, it is your responsibility to continuously replicate the changes I make in my primary to all of my secondaries. Now, if I want those secondaries to be readable, I need to use Premium SQL. But at the point at which I'm ready to do this wonderful global deployment, I'm ready to step up and I'm ready to put more resources into the system. And Premium gives me a way to trade money for engineering resources and time, because you do not want to build this yourself. It just carries a lot of risk. So then at the point, as I have the continuous data replication flowing, I now have my code, which is automatically rolling out to staging across all my data centers. I have Azure Traffic Manager routing my data appropriately. I have my data being replicated, so each one of these I can hit. There are two caveats here. Most of the, I talked about easy way to rent your way to victory. Most of the monitoring solutions, what they don't do is give you a global roll-up to say that these 5 applications are actually one big service. You may have to invest some additional tooling in order to build that single point dashboard. Or you buy 4 monitors and you put them side by side. I'm not kidding. I've actually seen that done a number of times because it was quick and only required a trip down to Best Buy to buy time to do it right. Constant theme. And then we turn on the other things via Azure Traffic Manager, and we put our feet up and go, hey, we are now actually in pretty good shape. So to come full circle back to the story at the beginning, this was not exactly how that remediation unfolded. How it actually unfolded, because time pressure, scramble, communication paths, was in a 5.5-hour period, some wonderful folks from CSS and DX sat down, crunched through the website, and figured, okay, we can basically get this optimal enough to put into 3 data centers, all pointing at the same SQL database, with enough ASP.NET Output caching installed to survive, to buy us about 2 weeks. So that took 5.5 hours to get back live. And then in those 2 weeks, they went in and basically refactored all of the data storage layer in order to take advantage of real caching through Redis and optimize some queries. But again, that was a 5.5-hour downtime during a critical media event that could have been avoided. The actual real meta of the story there is a lot of folks use digital marketing agencies and digital media agencies. Okay, good, and I can get really candid. Different kinds of software are different. I've spent 10 years doing doing embedded development. I'm good at firmware. I've done about the last 10 years doing large-scale distributed systems. Gotten pretty good at that because I've made a lot of mistakes. If you sit me down and ask me to write a mobile application, if you get a stick figure, you're doing well because it's a different type of app. You make different choices. And there are a lot of agencies and system integrators that are very good at, they have a core competency. I've had 4 escalations in the last couple of years from the same root cause. A team who is phenomenally, amazingly good at doing mobile apps and digital experiences, but who has never built a scalable back-end system. They get chosen, and then they have learning moments. So if you're either in the position of building such a team, or if you're hiring such a team, make sure there's a balanced skill set, because you don't want someone learning about all of this stuff on your dime. All right. So this is turning on Azure SQL DB georeplication. I don't often come up and say that something that is like a really hard physics and engineering problem we've made absurdly simple, but in this case we really did. You go in, you pick your georeplication, you see which other data centers you want to replicate it to, you stand up some new databases, and if you're in premium mode, then they're readable. It actually works really well. All right. So if you haven't checked out that feature, highly recommend it. All right, quick recap in about the 6.5 minutes we have left here together before I throw it open to some questions. Fair warning in advance, if you don't ask me questions, I will ask you questions. Mine will be more awkward. So most of the changes I've talked about, they did not involve changing code. Changing code at the last minute is risky, it's dangerous, and under stress and strain, people will make mistakes. So let's avoid that. Let's use these techniques in terms of having a dynamic cloud environment to be able to add more capacity to the system to buy the time to do the code right, based on data and observation. When you need to grow and go quickly, it's a good thing not to have to write code. It's a good thing just to sign a small dynamic check. But unless you have a strong foundation to build on, unless you invested in observational telemetry by renting it, not building it, you won't know if you're up, down, moving forward, moving backward, moving sideways. You need to have a system architected to allow you to add more capacity and add more resources. And you need to pay attention to where are the single points of failure and work around them. Adding all the front-end capacity in the world will not save you from creating too many connections or creating a lock escalation in SQL and everything rippling back from that. You do have to watch out for those single points of failure. But ultimately, the biggest thing is if you're making data-driven decisions, if you have an easy way to look at a system, poke it with a stick, some people call it load testing, I have a more colloquial term, and see system response and make decisions there, you're in a much better situation, especially in moments of stress and crisis, to know that, am I making decisions that are making the world better? And you will make some that make it worse, but you'll be able to immediately go, wow, that just took us from like 100 ops a second to 3. We should probably back that change out. And because we invested in ALM, it's just backing a feature branch out. And because we tried doing that, and we had it as part of our culture beforehand in our day-to-day experiences, we weren't looking up the Git manual while the site was down, because that's never happened. I totally did that. All right, so thanks for letting me pontificate for 56 minutes or so. The mics are now open. Actually, one quick little thing. I know I have one more slide. Success is exhilarating and terrifying. It's the most awesome thing that can ever happen when you're building software. It's also terrifying if you weren't quite ready for it. And to be honest, a lot of times you're never actually quite ready for it. So get the foundations right up front. Insight is life. If the lights aren't on, you are stumbling around in the dark. Rent the telemetry and look at it. And spend your way to victory. Engineering time is too expensive. It's best to do that in a calm, measured fashion. My team has a clinic up on the 3rd floor. We'll be here all week. So if you have design questions, you have scenarios, you have interesting things you want to do, or you just want to come and make fun of us, by all means. We've got a great bunch of folks. We've got a lot of whiteboards, and we're happy to nerd with you. All right. So, yeah.
So I have 2 questions. So the first one is, in the geo-replicated SQL database scenario, how do writes to secondary data centers flow back to the primary?
I was wondering if someone was going to catch that one.
And the second question has to do, how does it deal with failures of the primary data center?
Yep. So I'll take them in order. So the first question is, hey, you kind of left out the part where you only had one writable primary. How does that happen? So there's 2 ways to handle this. One is you allow data mutation writes from any deployed instance, but in your code you actually have 2 connection strings. One is, this is where I go to read data. Another one is, this is where I go to write data. Again, or you say, I can only do writes on the primary data center. Or the third one, which is a significantly more engineering investment, which is you implement command query response segregation and essentially use message-driven updates. But that's a lot of work. So the second one is around what happens if that primary database itself fails over. You have 2 options. You can die, which is the easy thing to do, or what you can do is put the system in a reduced response state, saying that write workloads are temporarily offline, and then just continue to read from cache, or if you want to add the engineering investment, start reaching out across the network to the other secondary data centers. Again, it's just how far down that click stop of engineering investment do you want to go? Where's the ROI? No right answer, lots of wrong answers, but no one truly right answer. That's great. I was hoping someone was going to pick up on that. All right, I think we got time for one more. If someone doesn't ask one, I'm going to ask one. Oh, no. Come on, I'm not that bad. Well, at any rate, like I said, if you have design questions, you just want to walk through scenarios, you want to kind of just hammer on some stuff, so we'll be around for the rest of the week. We're more than happy to go into any amount of detail. Highly recommend check out the stuff we have on GitHub. Tons of detail there. We love PRs, we love issues, we love discussion. And other than that, I hope you guys are enjoying the conference and have fun with the rest of the build.